Hello everyone, this is Hajin Tian. Today's video we are learning 5.1 fundamental identities. Here we have a table lists all the trig identities. First one is reciprocal identities. Cosecant, sine, they are reciprocals. So cosecant x equals 1 over sine x. Sine x equals 1 over cosecant x. Secant, cosine, they are reciprocals. Cotangent, tangent, they are reciprocals. Quotient identities. If I have tangent x, that equals sine x over cosine x. If I have cotangent x, that's cosine x over sine x. Pythagorean theorem. First one is sine x squared plus cosine x squared equals 1. Tangent x squared plus 1 equals secant x squared. 1 plus cotangent x equals cosecant x squared. So we will use the Pythagorean theorem, Pythagorean identities a lot in chapter 5.1 and 5.2. Okay, so what's the meaning of the sine x squared? So this has the same meaning like the sine x, all of them squared. So remember that this square represents I squared the sine x. Even or odd identities, we only have two trig functions. They are even functions. They are here, cosine and secant. That means these two functions, they are symmetrical along the y-axis. So every time, if I have an odd function, I input the negative x, I'm having negative sine x. So for example, I input the negative x inside the cosecant, I'm having negative cosecant x. Tangent negative x equals negative tangent x. Cotangent negative x equals negative cotangent. Only for the cosine and secant, you input negative x, then you have the output cosine x and secant x. Okay, let's see the following examples. The question is, write each expression in terms of sine and cosine, and then simplify the expression so that no quotients appear. And all functions are the positive or positive theta only. Okay, so the following question, we want to simplify the terms. And also, we want to have no quotient appear. That means I cannot say have this. So I cannot have this. I need to continuously simplify this. This is tangent theta. All right. Okay, let's see the first example. I have cotangent theta times sine theta. If I want to simplify this, I can convert all of the cotangent, all of the trig functions into the sine and cosine. Cotangent equals cosine theta over sine theta. Don't forget we have sine theta. So the sine theta, they are canceled. I have a cosine theta. Okay, let's see next one. Next one is secant theta times cotangent theta times sine theta. Let's convert all the trig functions into the sine and cosine. Secant equals 1 over cosine theta. Cotangent equals cosine theta over sine theta. Then times sine theta. Okay, this sine theta, they are canceled. Cosine canceled. I got 1. Okay, let's see next one. Cosine theta times cosecant theta. What is that? Let's simplify this. Convert them into the cosine sine. Cosine theta times cosecant. That's 1 over sine theta. Okay, what is the cosine theta over sine theta? That's cotangent. So we got cotangent theta. The solution is not necessary to have the sine and cosine. We just want to have the most simplified form. Next one, let's see. sine theta squared times cosecant theta squared minus 1. Okay, how to simplify this? Can I distribute the sine theta squared? I can do that. I can also think it in another way. What is the cosecant theta squared minus 1? We have the identity. It says if I have the cotangent theta squared plus 1 equals cosecant theta squared. This is a Pythagorean identity. So next step, subtract 1 both sides. Oh, I'm having that cotangent theta squared equals cotangent theta, cosecant theta minus 1. Okay, that means in the parentheses that that's cotangent theta squared. I have sine theta squared times cotangent theta squared. Okay, so sine theta squared, I don't need to convert it to the sine cosine, but I know that cotangent theta squared equals cosine theta squared over sine theta squared. So this one and this one, they are the same. I rewrite it. Now I can do the cancellation, top and bottom. The solution is cosine theta squared. Okay, so you say, can I rewrite this one? Because I know that cosine theta squared is 1 minus sine theta squared. Yeah, if you have this solution, you got full credit. If you have this, you get full credit. Because I know that sine theta squared plus cosine theta squared equals 1. If you want to isolate the cosine theta squared, that is 1 minus sine theta squared. All right, let's see next example. Number 61, if I have 1 minus cosine theta times 1 plus secant theta. Okay, how to simplify this? Let me ask you. If I look at the first parentheses, can you do some simplification or can you convert it to the simplified form? No, I have no way. I haven't learned the identity. How about second parentheses? I didn't see any method. So how about distribute or FOIL this one? Okay, let's FOIL it. So if I don't know which way I can simplify, so try any method you have learned. Okay, let's see. 1 times 1, 1. 1 times secant plus secant theta. And the negative cosine theta times 1 minus cosine theta. And the negative cosine theta times secant theta. And 1 plus secant theta minus cosine theta. What is cosine times secant? So secant is the reciprocal of cosine. So this one, secant part, cosine theta times 1 over cosine theta. Oh, this is 1. So I got a 1 here. So this one, they are canceled. Solution is secant theta minus cosine theta. Okay, we'll simplify this one. How about next one? So if in my expression has a negative sign in the angle part, we must use the even or odd property or identity to get rid of the negative angle. Okay, on the top, we have 1 plus tangent negative theta. We have learned if I want to get rid of the negative, tangent is odd function. I can move it in front. Okay, I'm having a 1 minus tangent theta. And how about the bottom? Bottom, we have negative. I can move it in front. So let me erase this. Then I'm having negative tangent theta. I want to have the positive bottom. So I can multiply by -1 top and bottom. So you can skip this step. You can do some other steps. It's -1 plus tangent theta. And then bottom is positive tangent theta. So let's separate the tops. We have -1 over tangent theta plus tangent theta over tangent theta is 1. Let's continue to simplify the first term. -1 over tangent theta is negative cotangent theta because the reciprocal properties plus 1. So you got full credit if you have this. Or you say, can I swap the 1 and negative cotangent theta? So, or you say 1 minus cotangent theta. Okay, let's see next couple of examples. The first one on the top, we got the negative sign again in the angle part. Let's get rid of the negative. But let me ask you, if I have cosine negative theta, that is cosine theta. And then I have a squared. So you square it. So I'm having 1 minus cosine theta squared. Okay, how about the bottom? 1 plus what? So let's see. So get rid of the theta first. So tangent negative theta equals negative tangent theta. And the squared means square all of them. So that is tangent squared. Tangent negative theta squared equals negative squared positive tangent theta squared. So this is plus tangent theta squared. Okay, let's do the simplification. What is the top? The top is sine theta squared because sine theta squared plus cosine theta squared equals 1. So if I have 1 minus cosine theta, so minus cosine theta both sides. Cosine theta squared both sides. I'm having a sine theta. So the top is sine theta. What is 1 plus tangent theta squared? So that's a Pythagorean identity. That's the second theta squared. And then let's do the simplification. We need to convert the top and bottom to the sine and cosine. The top is sine. And second theta squared is 1 over cosine theta squared. And do the algebra. And we have sine theta squared times cosine theta squared. Okay, let's see next example. Secant theta minus cosine theta. If I want to combine these two, they must have the like term, or they must be like term, but they are not. We can convert the secant to be sine and cosine. Secant theta equals 1 over cosine theta minus cosine theta. If I want to combine a fraction or combine fraction and integers, they must be the fraction and has the same bottom, same denominator. So the first term is 1 over cosine theta, and the second term is cosine theta squared over cosine theta. They have the same bottom, cosine theta. So we have 1 minus cosine theta squared. On the top is sine theta squared over cosine theta. So the top is sine theta times sine theta. And the bottom is cosine theta. What is sine over cosine? Tangent. So tangent theta times sine theta is the solution. Okay, let's see. Next one. Secant theta plus cosecant theta times cosine theta minus sine theta. Okay, how to simplify this? So I can follow it. If you can also convert secant and cosecant into the sine and cosine. So you have so many methods to solve this. If I want to follow it, how to expand the expression? So secant theta times cosine theta minus secant theta minus, times negative sine theta plus cosecant theta times cosine theta. And then this is positive, negative. I'm having negative cosecant theta times sine theta. I pull out the negative sign to here. Let's make it smaller. It's too big. And my next question has no space. So let's rewrite it. Secant theta times cosine theta. And then secant positive times negative. I can pull out the negative sign in front. So I'm having a negative secant theta times sine theta and plus cosecant theta times cosine theta, and then minus cosecant theta times sine theta. Let's do the simplification. Secant and the cosine are reciprocals, so the multiplication is 1. And then minus secant theta. So what is secant? Converted to the sine and cosine is 1 over cosine theta times sine theta plus cosecant is 1 over sine times cosine theta minus cosecant theta and sine theta, they are reciprocals. So it is 1. First term, last term, they are cancelled. So we only have the middle term. And the negative 1 over cosine theta times sine theta. What is that? That's tangent theta, because I know that sine over cosine is tangent. So I'm having a negative tangent here. And how about 1 over sine theta times cosine theta? That's cotangent. Okay, plus cotangent theta. This is the solution. You can also swap the two position. You say or cotangent theta minus tangent theta. Okay, let's see next one. Next one, if I want to distribute the sine theta in the parentheses, what do I have? I have sine theta times cosecant theta minus sine theta squared, and the sine theta times 1 over sine theta. Oh, the first one is 1. 1 minus sine theta squared. It is cosine theta squared. So memorize that. We have the Pythagorean identities. So if I have 1 minus sine theta squared, that is cosine theta squared. Okay, let's see. We have 3 more left. Next example, if I have a fraction on the top, 1 plus tangent theta squared. So when I see 1 plus tangent theta squared, that is the Pythagorean identity. That is secant theta squared. And the bottom, 1 plus cotangent theta squared. What is that? That is the secant theta squared. Okay, what is the secant in the sine cosine form? That is 1 over cosine theta squared. And the bottom is 1 over sine theta squared. And then we have 1 over cosine theta squared times, so KCF, keep the top fraction, change the division to multiplication, and flip the bottom. Sine theta squared to the top. So the sine over cosine, that's tangent. So the tangent theta squared. Okay, what is the next? Let's get rid of the negative sign first. That's cosecant. And the cotangent, it is the odd function. That is negative cotangent theta. next step, the top is 1 over sine theta, and then divided by negative cosine theta over sine theta. Use the KCF, 1 over sine theta. And then, so you can move the negative sign in front because positive over negative is negative. Multiply by sine over cosine. I'm having negative 1 over cosine. What is 1 over cosine? It's secant, so we have negative secant theta. Okay, let's see last one. Last one, I'm trying to get rid of the negative angle theta. So first one, I have a big parentheses, and outside is the squared because I want to get rid of the negative sign in the theta part. So sine is odd function. I'm having negative sine theta, and plus tangent is even or odd. It's odd, so negative tangent theta. And what is cosine? Cosine is even function, so I can ignore the negative sign. Second step, I square a negative number, I'm having a positive number. I have sine theta squared plus tangent theta squared plus cosine theta squared. So first term, last term, it is 1. 1 plus tangent theta squared. So can you move on to continue simplify the two terms into one term? Yes, 1 plus tangent theta squared. It is secant theta squared. Okay, so we're done for today. If you have any question, please let me know. Have a good one. See you next video.